Okay, so in the previous video we learned that in the folding that we had, it proved that our three angles of the original triangle added to be 180 degrees, but it also introduced us to what we are going to learn as a new term today, which is a mid-segment. Segment EF is in the folding connecting points E and F. And remember, we already decided that E and F are both midpoints of their sides they're on. So E is the midpoint of segment AB, F is the midpoint of segment BC. We can show that with tick marks. And remember, one apiece over here, two apiece over here, to show that these lengths are not the same. So we also learned that the length from E to F was half of that from A to C. So in mine, A to C was 12 centimeters long and E to F was 6 centimeters long. But this segment right here is called a mid-segment. It's called a segment because it starts and stops, and it's called a mid-segment because it connects to midpoints of a triangle. Now, a triangle has three sides. So all three sides of those triangles will have midpoints. So every triangle will have three mid-segments. You connect these two midpoints for one mid-segment, these two for another mid-segment, and these two for a third mid-segment. So all triangles will have three mid-segments. It's just a segment connecting two midpoints of sides is all that is. So we learned a relationship about that the mid-segment's length is half of that of the side that we'll see is going to be parallel to. So EF and AC are also, we're going to learn, are parallel to each other. So if I gave you a triangle and I told you these are the midpoints, and I'm just going to call them A and B here, then I would know that the segment connecting them is a mid-segment. So if I told you that the length from C to D is 20 inches long, you would know the length of A to B is half of that. It is 10 inches long. That's the relationship between the mid-segment and the side that it's parallel to. Okay, so what we're going to look at is, again, the triangle sum theorem. Once we prove it, and we're going to look at another proof in just a moment, then that conjecture becomes a theorem. And it just says the sum of the measures of the angles of a triangle is always going to be 180 degrees. Now, it has thrown in a word here that we typically don't say when we quote the theorem. It says the measures of the interior angles of a triangle. We will talk about exterior angles as well. So we're just talking about the angles inside a triangle adding to be 180 degrees. So on our proof, we're going to have to review some properties we learned in topic 6, I believe, way back when we were learning about parallel lines cut by a transversal. And we learned different types of angles that have special relationships. So two of those are the alternate interior angles and the corresponding angles. Both of these pairs of angles are congruent, meaning they have the same degree measure. Remember, alternate interior angles mean they're on opposite sides of the transversal, but inside the parallel lines. So for example, these two that have two arcs are alternate interior because they're on opposite sides of line T, but inside lines J and K. These with one arcs are also alternate interior. Remember, it's not called opposite interior, they're called alternate interior angles. Corresponding angles are on the same side of the transversal. They're also on the same side of their parallel line, meaning one's going to be exterior and one's going to be interior. So these two with one arcs are going to be corresponding. They're both to the left side of the transversal. This one and this one are both above their parallel line, which makes this an exterior angle, but this an interior. They're going to be congruent in measure, and you can see they're both obtuse angles in this drawing. These with two arcs are also corresponding. They're to the right of the transversal and above their parallel line. These pairs are corresponding, these pairs are corresponding. Notice we used one arc for both of these because remember vertical angles are congruent, same here. So we only have two measurements in this whole drawing when we have parallel lines. We have an obtuse measurement, let's say if this one was 120, And we have the acute measurement that has to be its supplement. Since they make a linear pair, they have to be supplementary to one another. So once we know one measure, I know all 8 of those using all the properties that we've been talking about. So let's look at our proof on our notes from number 7. So you have on number 6 just a reminder of what the triangle sum theorem is. You also have the definition of midsegment included in number 5. But in number 7, we're going to fill in this flowchart proof. Remember, we have 2 different types that we mainly focus on, the 2-column and the flowchart. But this one's a flowchart proof where we are given a triangle and we want to prove that the measures of the 3 interior angles of that triangle add to 180 degrees. Now notice it didn't call one of the angles by its vertex name. We didn't call this angle angle B, because we're going to end up as part of our proof drawing a line through B, which creates more than one angle that has B as a vertex. So remember, you can only use the letter that's the vertex of the angle if that's the only angle that has that as a vertex. So B we cannot call angle B because there's 3 different angle B's in the drawing. So we have as our first step to draw a line J through point B so that J is parallel to segment AC. So we talked about in last topic that if I have a line, there are infinitely many lines parallel to it. I could, for the rest of my life, draw lines that are parallel to that line. But if I want it to go through a specific point and be parallel to the line, well, now there's only one that exists. And so if I want to go through point B and be parallel to segment AC, there's only one line that's going to do that. And we have called that line line J. Now by drawing that line, we have created 2 exterior angles to angle B. So now we're calling them by numbers, and so angle 2, angle A, and angle C are the 3 angles of the triangle we're trying to prove are 180 degrees, so we can prove the triangle sum theorem. Now, since we have parallel lines, we have those relationships that we just reviewed about corresponding angles and alternate interior angles, and all those angles that we learned are congruent because of parallel lines. And we have one that's one of our choices here. In this flowchart proof, I want to just point out that it's a little bit different than some of them where we've put the statement and the reason all in one box. In this one, it has a statement with the reason right below it. So these are going to be statements, and these are going to be the reasons for those statements below it. This is going to be a statement and its reason. So I just wanted to point it out. It's a little bit different than some of the ones we've looked at. So we're going to use the fact that we have parallel lines to say that when we have parallel lines, we know the alternate interior angles are congruent. Well, what alternate interior angles do we have here? Well, here are my parallel lines, and we have 2 different segments that are intersecting them both. AB is intersecting J and line AC, and so is BC. It's intersecting line J and AC. So both of these sides of a triangle are a transversal. So I'm just going to kind of cover this one up and look at just this side first. So here's my parallel lines, and here's my transversal. If you'll remember, alternate interior angles make a Z together. So anytime you have parallel lines cut by transversal, the ones that are alternate interior, you can see they make kind of a Z shape together. And so if I kind of make a Z shape with that transversal, maybe that'll help you see which ones are the alternate interior. They're angle 1 and angle A. You see that Z shape there. So we know the measure of angle 1 has to equal the measure of angle A because for parallel lines, the alternate interior angles are always congruent. If we ignore that transversal and look at BC as a transversal, we can see a backward Z created with the alternate interior angles, which are angle 3 and angle C. So you see that backwards Z. Notice I used 2 arcs over here because we don't know 1 and 3 are congruent, and we don't know A and C are congruent. I just know 1's congruent to A and 3's congruent to C. So you can see that's a choice in our given statements here, or our choices I should say, not given. The only thing we're given is triangle ABC. The measure of angle 1 has to equal the measure of angle A, and the measure of angle 3 has to equal the measure of angle C. Because again, what type of angles are they? They are alternate interior angles from parallel lines, so we know they have to be congruent. So that's what I'm going to put for the reason down there. For parallel lines, the alternate interior angles are congruent. Now, our second statement, we're given the reason for. It just says angle addition, and we're using the definition of a straight angle. So remember, angle addition just says the parts add up to be the whole. So if you have an angle that's split into two separate parts, those parts have to add up to the whole angle. And straight angles, remember, by definition have to be 180 degrees. We have a couple of different ones that add to get 180, but one of them is what we're trying to prove, right? So we know that's going to go last down here. So obviously it's this one right here. And let's look at the measures of 1, 2, and 3 and why we know that add to 180. Well, 1, 2, and 3 are the parts that make up this whole straight angle here. And so that's why that's angle addition. We're just saying these three parts add up to be the whole thing. And since the whole thing is a straight angle, we know that it equals 180 degrees by definition. So that's our statement here, is that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. The parts add up to be the whole, and since the whole is a straight angle, it's 180 degrees. So now we're ready to put what we're trying to prove, which is the measure of angle A plus the measure of angle 2 plus the measure of angle C equals 180 degrees. But what allowed me to go from this equation to this one? Well, we can see the similarities. They both have the measure of angle 2 and they both have 180 degrees. But what allowed me to replace measure of angle 1 with the measure of angle A? The fact that I know they're equal. What allowed me to replace the measure of angle 3 with the measure of angle C? The fact that they're equal. So remember, anytime you're using the fact that two things are equal to replace one with the other, you're using substitution. So that is another just proof of the triangle sum theorem, and it's using what we call an auxiliary line when you add a line of your own to help you with the proof.